Hello everyone. So let's start solving today's problem. So today we have delete a node in a single linked list. Right. So in this problem we have been asked to delete the xth node of in a single linked list. Right. So for example, if you had been given that the nodes, the single linked list is like 1, 3, and 4. So clearly, as you can see, the third node is this one. So the first operation comes up in your mind is this is one based indexing, right? So this is the very first node has an index 1, then 2, then 3, right? So if they have asked that delete the third node, which means we'll be deleting the fourth node, means the node which has value 4. And then we will simply delete it and assign the 3's next as the 4's next address. 4's next was null, right? There was no other node next to 4. So we will simply assign null here. Okay. So now let's look at the second test case in which we have 1, 5, 2, and 9. And they have asked to delete the second node. Second node means to delete this 5 since this is a one based indexing. So 5 will be deleted. And 5's next is if I delete simply 5, we would lose the address of, we will lose the track of 2 and 9, right? Since 5's next is holding the address of 2. So what we'll do, we simply updates one's next to 2, which means we will, what we'll do, since if my P were here and Q were here, we simply assign P's next to Q's next. All right. So we'll simply update the address and return the head node. Head node is currently pointing the at the start. Okay. So let's look at the implementation part. So here are the edge cases that have handled. If there is no head, which means the linked list is null, we'll simply return null. And if there is only one node in the linked list, then we have to delete that very node, right? So we'll simply return head next. Okay. So I mean to say that if we were given 1, 2, 3 and value of x was 1, so this means that we would have deleted the very first node, right? So we will return the linked list from here. So from 2, 2 is nothing but heads next, right? So that's all. Now, if P is next exists, if any other node exists after P is currently pointing to the head node, okay? So we will assign Q to P is next. So let me write the test case here so that it would be easy to understand. And X is 3. P is initially here. And if we have any other node, we will place our Q pointer on that. Okay. Now, while X is greater than 2, so if my value of X is greater than 2, which means that in this case, we have 3, right? So what we'll do, we'll move the P pointer here, which means at Q and then Q at 3. Okay. And we decrement the value of X. Since, let me write the index first, 2 and 3. So initially, our P was pointing at this one. And since we moved further, which means that value of X has been decreased. As you can see, now value of X is 2, right? Initially, the value of X was 3. Since we have moved by one node, it has decreased to 2. Now, we again check if the value of X is greater than 2. So, is it greater than 2? I don't think so. So, what we'll do here? we'll simply update the address, which means P is next should point to null, and we simply delete this queue, right? And we simply return the head. Now let's look at the case when the value of x were given 2. So in this case, simply we put P here and Q here. Now we are we are we check the condition of while loop if x is greater than 2. So clearly our x is not greater than 2, right? So what we'll do, we'll simply update the P is next here and delete this intermediate node Q, since we have been asked to do so, right? And we simply return the head. So I hope you get the implementation part. Let me show you that it works completely fine. All right, thank you.